Thanks for having me, actually. It's a pleasure to be here. So basically, we are already doing Gracia for 1 year, and we are kind of a big team, 16 people. We are a startup. We raised our previous round, the first round, then closed it in March this year. And originally we launched as static thing, but since the very beginning, we thought about delivering volumetric videos. That's what we were raising money for. And now we kind of when you start a new project, you always go very wide, trying to explore all the opportunities. And like the more you talk to investors, to potential clients, to the community, to the founders, you realize that you need to focus more and more. And now we think that volumetric videos that I'm going to cover and the use cases that we use, that we find as a target use cases, are all about like human performances, like using these volumetric videos of completely lifelike, very photorealistic, etc. So Gracia last December was launched as a community platform for sharing static scenes, and we are around 10,000 monthly active usage, which we are really proud of. So people are either coming to try in VR Splats they are published, they probably trained it in Canniverse, for example, they uploaded the PLY file, now they can enjoy their Splats in VR. So we are at Gracia, they're really focusing on XR. Yeah. So, but now finally we ship volumetric videos. A very brief introduction about us. Me and my partner, Andre, we are friends since high school. My partner is leading technical part of it, R&D, engineering, and I'm responsible for business development and marketing. We are second-time founders. We have our previous project successfully done. And now with a team of, as I mentioned, of 16 people, we already got into this project. So coming back to the technology of dynamic Gaussian splatting. Yeah. So basically, if you imagine the evolution is that you scan the static thing in Splats, right? The next step, you can capture many frames and train them separately, independently, I would say. And they play back them just naively, one after another, and you get a volumetric video in some way. So you're going to face a lot of temporal inconsistency, you're going to get flickering, and that's what we started with. So we were shooting content in 4D scanning studios, we were obtaining frames from the cameras, synchronized footage. We took each frame, trained it separately, put it all together. It weighs a lot because you need to store each frame separately. And here comes all the issues with the quality, right? So now we have achieved volumetric videos that are stored, I would say, as already in a compressed way, where we store not only each frame separately, but we kind of track the tractions or of the splat, and it allows us to do lossless compression. We have achieved 15x lossless compression, and now we are at 9 gigabytes per minute, which is still a lot. Obviously, still a lot to ship it to consumers, but we have a plan. Our R&D team has a plan how to make it three times less. And what we are speaking about is like 360 volumetric videos, which means that you have full freedom to move around, right? So you capture it having like around 40 cameras from all the angles. Let me show you the trailer. I think should work fine. Sorry that it's just linked to our Twitter. A bit of self-promotion, I would say. Yeah, but here we go. Oh, sorry, let me turn off the audio. Yeah, so these are the examples, right? I will continue explaining. So when you start to train frames, not independently, but all together, or with like in batches with a bit of intersection between them, you start getting things like infinite frame interpolation. You achieve temporal stability, and the quality is improved altogether. Also, we added diffusion models to fill the gaps. For example, you didn't have camera to capture the neck from the bottom, right? And you have a gap there. So you can use diffusion models to kind of to avoid this, right? And to hallucinate the chin, for example, and at least you have some kind of a chin. It helps to improve the quality. And Another important thing is Splats allocation. So if you define the most, as we call it, points of interest, so the face, the tattoos on the model, etc. So you put just on the training side, you put more Splats in there. So in this case, you kind of redistribute Splats and like put less Splats on the floor, more Splats on the person, and you just achieve the better quality and better fidelity altogether. So I'm, as I mentioned, I'm not the technical guy, so I could share some things, but I probably couldn't share like insights or anything that we consider that our secret sauce. But yeah, that's how it works. And overall, what we are like particularly proud of is that um, we are not only achieved kind of a training pipeline and made these videos possible, and like you basically have many startups who can train volumetric videos in different ways, right? But our kind of key focus right now, and it was for quite some long time, to ship it to consumers in VR. And we released volumetric videos for PC VR recently, and hopefully this or next week, we are going to release it for standalone Quest 3, which was extremely ambitious in the very beginning when we planned to do it, but seems that it is achieved. Yeah. And after that, we will focus on integrations with Unity, Unreal, etc., to make it possible to run in other applications. Because currently, in order to ship it to consumers and make it run on standalone headset, we had to build a proprietary engine from scratch, just to squeeze everything from the device, and like there are a lot of tricks that we use in order to make it run in real time, because rendering for VR is much more challenging because you have two eyes, much higher resolution. You need to render it at 72 FPS in order to avoid motion sickness. And overall, these volumetric videos are unlocking, as we call it, new type of experience, like net generation of immersive content, right? And there are a few important things to be added, which are mixed reality environmental depth support, which we recently released. It allows you to merge the event that was captured in your environment in an extremely photorealistic way, considering all the I would say all the objects that are in your room, right? All the occlusions. Hands tracking, obviously, to easily navigate inside of this scene, rebind it, etc. So here is an example of cooking masterclass with a professional chef. It's still a tech demo for us, but for cooking use case where you have your hands dirty, it's extremely important that you can navigate inside of it using hands. And the parallax effect that you get in VR, it's just that's why we focus on VR specifically, and later going into 2D devices. I will cover it. I think that it might be curious for you to learn more about like content production. It consists of three major steps. The first one is capturing, and you have basically three areas that we can consider like how the content might be captured. The AAA quality is currently achieved when you capture content on in a 4D scanning studios. You have plenty of them across the globe. We have partnered, integrated with a few of them. So they have cameras 360 around you, but you're very limited with the space inside of the rig because the rig usually is quite tiny. You barely can capture more than 2-3 persons inside of it. And we have, like, speaking about like family moments and reliving the events, we capture the family, and it worked extremely nice. And we captured it in Infinite Reality, is one of the most famous, I would say, and most high-end studios in this field. So that's the way how you can achieve AAA quality of capture. You have real-world or on-site shooting when you do a portable rig, you synchronize cameras, and the most challenging part actually synchronize cameras so that they capture extremely like with 1 millisecond delay between the frames, right, from each camera. And basically this problem is kind of solved as well. You have solutions like Genlog that enables you to trigger cameras to shoot simultaneously. But the next big thing I would say that we see upcoming in a year or two is semi-real-time streaming, leveraging the existing cameras, right? When I was fundraising, I was always pitching the UFC fight as a target example. You have a very small, like quite small, okay, not very small, like octagon with fighters, only 2 people, and they already have 20 cameras to capture it for broadcasting. So you just need to obtain the data from those cameras, train them as fast as you can, and do the streaming to user device. In this case, you enable a completely new type of experience for sports. When in the mixed reality, you can have these fighters fighting in your room. And we will cover like target use cases, I think, on the next slide. So the net once you obtain the data, you have the training part of it, yeah. And there are two kind of stages. You need to process it first, and currently, we do not provide our training pipeline as a service. And some people ask us about it, something like for both static scenes and volumetric videos. But as it really requires a lot of thought put into it, and parameters to be tuned for different types of capturing. Either you capture outside in, inside out capturing, it's different. You capture static scenes, one parameters, you capture videos, like another parameter, you capture an animal, different, like you need to adjust, you capture people, need to adjust, etc. So that's why we are trying to work on this pipeline internally before we provide it to the community. And the second part, which is necessary to ship it, is video editing. So sound mixing, color correction, everything which comes with it. So it's not on our plate right now, but we plan to work in this direction or to collaborate with existing toolkits for volumetric video editing. And then obviously you need to ship it to consumers. What are the two options you have? Basically, you have on-device rendering when you upload all the data on your device, full video, and you play it back on device. Compression is the most important part. We achieve kind of arbitrary length volumetric videos, but we ship consumers only short sequences of it just to save their time on downloading it. But the second part is the second opportunity is streaming, like either cloud streaming, well, how Hyperscape does, right? When all the calculations are done in the cloud and only picture streaming is done to the device, or when you stream basically the Splat, you stream it with the same speed that you can play it back on device. That's a part of our pipeline for the next year. I think that one of the most important steps to make volumetric videos based like dynamic Gaussian Splats widely available and widely used is to avoid the upload of the file before you play it back on device. So it will both just improve user experience and widen the funnel of a user headset that can be used for it. So now to the main topic of the presentation, right? So we consider 4 major industries for it. First one is what we call improving skills via observational learning. So it's kind of any type of complex technique, and it's B2C part of it, right? Where a person does a particular technique, performs a technique that you barely can follow in 2D. Dancing, sport, fitness, cooking master classes. We consider that, we think that in VR specifically, it will be extremely helpful to stand close to the person and rewind it easily, watch it from all the angles, just because observational learning is just part of the learning curve. The second one is the same, but for B2B, so medical use cases and employee onboarding. We see a lot of opportunities in this field, a lot of applications for these technologies. Entertainment, it's more like one-off events, but still has a huge marketing and viral potential. And like when Nathan said about like what's important for Splats to be widely used, I think that such type of wide audience use case with celebrities involved, with big brands involved, is extremely important to make people aware of the technology itself, either it's static things or dynamic, never mind. And the last one is specific application for VFX for advertising that we find attractive as well, simply because I have even a separate slide dedicated to. So you can capture a 3D view, like a volumetric video, right? You process it. Now what you have a volumetric video that you can, even if you capture 25 FPS, you can re-render it like for 500 FPS, right? 500 frames divided by 500 frames per second. Exporting units or unreal, compose it with any environment you want, and create enforceable fly-throughs because you have a full flexibility on post-production on a virtual camera. So you kind of can re-render it. Okay, it's not a real-time experience, but it works for this particular industry. So you can create this wow effect that needs to be delivered like if it's like VFX project or advertising project. So we really believe in this use case and trying to connect with the creative agencies on this. An infinite frame interpolation, it comes. That's what I basically explained with when you train the trajectory of Splat, you can interpolate with much higher frame rate that you originally captured the content, and so you have kind of under the hood you have all the bullet time, slow-mo, etc. Just by design how it works. So we find it very attractive for uh, for this industry. Just very briefly, I will show you this demo because we really like it. We think it's fun. It's just a family dancing in lava. A bit of a joke. Yeah, that's basically it. One last thing I wanted to mention is that we consider ourselves as a deep tech startup, right? And I'm currently the only one who's responsible for business development. So we can't boil the ocean and to reach out to everyone ourselves, every particular company. And you see that there are plenty of use cases. So if there is anyone who is building something for XR in these industries, we would really love to collaborate providing our technology because we find the best way to make it widely available is to suggest it and propose it to your existing client, simply because we can't make technology, content production, and business development ourselves. So we consider ourselves more like a technology provider and technology partner. Thank you so much.
Thanks so much, Georgii. Really great talk, and I know it's a topic that's quite of the moment. I think there's a lot of us out there who are working on volumetric video and look at what you're doing and see what a high standard you're doing it to. So it's really exciting. I'm gonna cut straight to the questions. So Jim F is asking, can you describe the pros and cons of your approach compared to more traditional volumetric video?
Basically, it's it's applicable for both static and dynamic Gaussian splats. Um, it's just the quality of the output and the flexibility you get, right? So with meshes, you barely can work with like semi-transparent surfaces, reflective surfaces. Hair is usually the most challenging part. Tiny details on the face is challenging. With Gaussians, you can have a semi-transparent drift, and you can uh, as like as how it works, right? So you kind of AML remembers the information, how each particular point of surface looks like, depending on the angle you look at it, right? So it enables all view dependency effects. And these view dependency effects enables content to be that photorealistic. And photorealism is all about shadows, tiny details, defects of the skin, everything which was really not possible with the prior technologies, I would say. So this is the biggest part, I would say.
Are there any aspects of working with Gaussian splats that make it harder than if you were to try to do the same thing, say with polygons, with textured meshes?
I can't say that it's harder, but the content production process is a bit different. So we usually the same equipment, the same cameras can be used, right? But like both for static scene scanning or for volumetric videos, you just need to adjust cameras. You need to keep in mind a bit of details about how it works. So we usually change the lenses on the cameras, we reposition cameras a bit, etc. So I can't say that it's uh, more challenging to do Gaussian spots because cost of production of them, so the processing cost is very, very similar. And so, but it just provides you more opportunities, but you need to adjust the content production a bit and have this expertise how to capture it properly to get there.
In your presentation, you gave an example of, I guess, a representative example of the number of cameras being used to capture. You mentioned, I think, 80 to 90 for 360, and a lesser amount, I think it was in the 20s for a, let's say, 180-degree semicircle. And it's something I've been quite interested in, and it's popped up here in the questions, and it was and you're using AI to optimize your process. And a question from anonymous attendee who asked a lot of questions. Do you think proper 4DGS reconstruction will be possible with a single camera with the help of generative AI? And they mentioned some papers, which you've probably seen, where people are doing reconstructions with monocular video. What do you think about this?
Our position here is the following. When I say our, it means that I don't have a position. I just ask it from my partner, myself. So the Gen AI will definitely help to reduce the number of cameras required. So originally we thought that like 160 cameras is required to capture a proper volumetric video. This demo is captured with only 40 cameras and it's 360. And you're absolutely right that 20 cameras is more than enough for a 180 video. Now, I mean the volumetric, like the viewpoint freedom you get. And transportable rigs we are now exploring are 15 cameras only, like in the modular ones, so that you can easily put those cameras in the right positions, right? So 15 cameras can be enough. With Gen AI, I think that it will help us to reduce in a short term, like or middle term, let's say 1 or 2 years, it will help us to reduce the whole industry, to reduce the number of cameras required. So it will reduce the cost of production, obviously. However, we don't see that the magic is going to happen. If you capture Messi from the front, you barely can imagine right now from to reconstruct him from all the so to reconstruct his back that it's number 10 and Messi now number 30, I think, right now. So you barely can imagine these like already now, right? So we think that reconstructing 360 videos using one camera is really not there yet. But speaking about like limited viewpoint freedom videos, as we call it, couch VR experience, when you sit on a couch and you just only rotate your head a bit without moving around the scene. It's already possible, and you have startups like Immersive, for example, who do this. But I think they use not Gaussian spots; they use a bit different technology. It's just two different types of applications, and if you if you look again at our target use cases for our particular like 360 volumetric videos that we are working on, these experiences are more likely to be valuable watching them from all the angles rather than in a couch VR mode.
Yeah.
But I can easily imagine family moments, for example. That's why we do not include it in our pipeline, in our target use cases. Like family moments, and the guys from Immersive, they have a few very, very good scans of family moments. I can imagine them being in a couch VR mode captured with either one or two cameras. So yeah, that's a bit long question answer. Sorry about
Yeah.
that, but it makes sense.
No, I'm really glad you got into it because I think it's a question that a lot of us are asking ourselves, right? Should we invest in a rig with 100 cameras, and might that to get great results today, but might that be overkill in a year when it turns out by using Gen AI you can get away with 25 cameras or 15 cameras or whatever, or as Apple has been promoting with their phones, using stereoscopic vision to do 3D
Yeah.
reconstruction of the sort.
Yeah. One thing to add here is that it's sometimes it's not about number of cameras, it's more about the way you position them. And sometimes it's not about like the quality of the camera itself, that the quality of the image that it kind of captures, but rather the synchronization of cameras, which is much more important. So the position of cameras and their synchronization is just contributes in the quality much more than the number of cameras and their quality, based on what we found out during this year.
Yeah, okay. Yeah, that makes a lot of sense. I think there's a question here which I'll ask, and I think you've already answered it actually, but I'll ask it anyway. And this is from Sam Smeep, who, thank you, Sam Smeep. You're often on these calls and you're often asking questions, and we appreciate that. What makes these conversations so interesting are actually the questions from the audience. So thank you. And what he asks is, will it be possible in future to upload our own videos like 3D models right now in Gracia? And will Gracia train the video itself? I think you may have already answered this question, but if you could just approach it.
Yeah, sure. So I think the first step will be to like what we already are open to, and we got a few requests already, is to share the data set with us, the synchronized footage. So we process it and publish on the platform, with all the regards, like, and a shout out to the creator. That's we are already open to do. Uh, what I mentioned is that we do not provide it as a service, as external service, because these it's still a bit manual in a way that we kind of tune the parameters we use for training to achieve the best quality possible, at least now. That's why we do not kind of make it external. If someone and the last part of it is that, as Nathan mentioned, the SPZ format, we have our own proprietary format as well that enables compression. But so kind of if Nathan does like JPEG for Splats, we do kind of MP4 for Splats in some way. Yeah. So we are quite limited with it. That's why uploading your own videos to our platform is unlikely to happen sooner than that we provide the processing pipeline as a service, right? So it would be, I think, just we'll be able to make it more quickly.
Okay, makes sense.
But feel free to reach out, please, to me if you have a data set that you would like to process, and we are all very open to share our ideas on the rig setup in more details, like to capture it.
I've got a lot to send you. I'll talk to you later. Here's a question from Alex Gee. Where do you see the advancements made with your approach to Splats in VR spilling over into the work being done in AR by Niantic? I wonder if maybe this is a question about how your work might relate to the spatial work and the sort of the global spatial work being done by Nathan's group.
It's a tricky question. It's a very strategic one. Like let's agree that the whole industry is very early, and everything can change down the road. Now we are proud to support mixed reality mode and depth composing, so that you kind of can compose the object, the volumetric video into your real environment. We Due to the scale of the startup, due to the scale of the team, we don't currently have any like that kind of long-term vision of kind of merging the technologies with Niantic or anyone else, right? But our first task and first priority is to make this perfect quality and widely available to consumers and make people aware of this technology, like via either marketing collaborations or commercial projects, right? So that's what we are focusing right now. We will see where it gets in the future. But from the technology perspective, like AR mode, when you kind of compose it with real world environment, is already solved. And later comes all the questions with integrations.
Okay. Let's see, what have we got? Is there a big difference? So Frank Laduzzi asks, is there a big difference in quality when viewing G-Splats on a standalone headset versus PCVR? Do you see a need for Wi-Fi/60 gigahertz wireless streaming G-Splats?
Very, very good and technical question. There is a difference between standalone and PCVR for us right now, but to be honest, I can't see. So our developers can, but I really can't. So I just don't get it. I see the same. So there is a tiny difference in performance, but we worked a lot on standalone optimizations in order to kind of, so the field of view is a bit lower, so we render it on the kind of edges. We render it in a bit less resolution because usually your eyes are like focused on it, like right in front of you. So there are some tricks to make it almost the same quality. But there is a difference, but like most likely consumers don't see it much. As for the streaming, we are currently are not focused on these Wi-Fi streaming that you mentioned, but we see the streaming opportunities that two things, right? So streaming it, so uploading it with the same speed that you can kind of render it on device, and picture streaming, which I mentioned. So these are two options we exploring right now. Yeah.
Okay, cool. So I guess maybe two quick questions. I think we're almost at time. One would be people would like you to put your slide back up for your contact so that they can bombard you with requests to
Yeah,
process
I
their
will be
4D captures.
more than happy.
And I'll do that as well. And then thank you very much. So everyone take a screen grab. Have at 'em. And then a question, just a somewhat random question. It seems, is Gracia aware of / associated with brain dance? I have no idea what brain dance is. Do you know about?
Yeah. Let's skip this question.
Okay, so we'll
No.
for another time. Okay. And then let's see, just maybe then we'll skip to another one, which is I don't understand it. I think you mentioned this before, but about the playback file format for your volumetric video. That's a proprietary format. Is that right?
Yes. For videos, totally proprietary. For static things, we support PLY files to be uploaded to be viewed in PCVR mode, because just it enables you more kind of like the device usually has higher GPU capacity, right? But for standalone headsets, we are currently supporting again our proprietary format. So we are like, that's why for standalone headsets at Gracia you have less content currently, because in order to ship it to standalone, we need to obtain from the creator the raw footage, process it on our pipeline, and with this optimized format for our needs that we can run real time on standalone, we can publish it. And it's part of my daily routine is to find creators and reach out to them, and of our marketing lead to reach out to creators who publish a lot at Gracia. We are trying to obtain the footage from them to kind of to make it more available, because we now reached 50-50 split between PCVR users and standalone users in Gracia. So, and we expect standalone obviously to grow. So
Okay,
that's
cool.
the strategy, right?
And then Alex, apologies. So the first time I read your question, I didn't quite understand, but now I think I understand. So Alex says, we've already covered talking about using generative AI to reconstruct from monocular vision, and now he's asking, can you use AI to take let's say the volumetric scenes you've created and to add interactivity to them?
Currently, we don't. As it's too technical for me, I would rather forward it to my partner.
Sure.
I know that it's not in our like 6 months pipeline at the moment. So due to basically resources limitations, for us, it's now more important to like kind of, we have achieved volumetric videos, we find it close to perfect quality. We need to make them integratable, to all our partners' applications like Unity, Unreal, etc. So just to for people to start using it, yeah, and to, like, if we talk about any fitness app, for example, or UFC app, you need to or ShapesXR, right? So you need to integrate with them first before you start making this content interactive. However, like relighting of scenes, so some part of interactions with it is already possible to be done, but like changing the way, like lip kind of make changing the way what person says is
Yes.
much more difficult
Yes.
at this point.
Okay, that makes sense. I think, I mean, if Felix, if you agree, I think we're at time now. So I think we'll close out. But so, Georgi, thank you so much for coming on. I mean, I think so many of us are working on 4D right now, and so it's really exciting to see someone. I think your team, you guys are sort of state of the art. I think, you know, the best there is out there. So it's really exciting to be able to talk to you directly and get your thoughts. So thank you so much for joining us.
I
And
appreciate it. I appreciate it. Thank you so much.